Over the past year, there have been large leaps in AI for generative 3D, which can be created from both images and text. They've improved in texturing, detailing, and mesh topologies. I'll show you how to leverage these to generate conceptual 3D designs, bring them into Unreal Engine. There are quite a few AI generative 3D models out there, from big names such as Nvidia, Microsoft, and Meshy AI. There are other proprietary models, such as 3D FY and Meshy. Out of these, Meshtron by Nvidia is looking to be the most promising in this technique for producing artist-usable rationalized topologies, which you can read about the scientific approach in a paper they published recently. However, this model isn't available to the public yet, so we will need to wait a bit longer. Next, Meshy AI has been around for much longer. It's not open source, but they have a very easy-to-use interface and offers free credits to try out. To use it, simply drag and drop an image. Ideally, it will be some kind of object or massing with the background blank. Just add a name and press generate. Meshy AI rationalizes these images and gives you a few options. It can sometimes differ quite a lot from the original image, so it isn't the best option if you want exact results. You can then select one, toggle on a texture, and then generate, and you'll have a texture to match this. So you can do this on as many options as you like and compare them. Next is Microsoft Trellis, which I'll be demonstrating with, as it is open source and produces good details. You can read about it on this GitHub, and if you scroll down, you will find installation instructions if you want to install it locally. You can also install this to work with ComfyUI, which is great, but as you'll see here, you need a GPU of 16 gigabytes, which is quite high. So for demonstration purposes, I will show you a much easier method using their Hugging Face app demo. This is also a simple drag and drop interface. I prepared a couple of AI-generated sculptural building types and deliberately made them complex to challenge the AI, to see how accurate a representation it can make of this. I also removed the background, although this demo has a built-in background remover already. You can pretty much keep everything as default and increase the sampling steps to try and increase the quality, although with previous tests I found it doesn't drastically differ. At the bottom you can also see some sample images that you can try out on too. All you have to do is press generate. I sped that up. Actually, it took less than 20 seconds. It is impressive that it has understood all the window recesses and kept in the windows. If you remember, in the Meshy AI app, made all these hollow. There's quite a big difference. And all the way around the model has been formed consistently. From here, you can extract a GLB file or a Gaussian file. I will go with the GLB mesh, and this will take a bit longer, about a minute to generate. But once complete, you have a very nice conceptual massing model. This demo does have a daily limit, but it is fine to try out on a couple of models. I'll try one more image, which is very organic and rather gaudy looking, with uneven lighting. Now you can see that the model has rationalized the balconies. It'd be more horizontal platforms, which I actually prefer, and kept the window openings. As you rotate the model, you will see, however, that some areas are under and overexposed, which I've sometimes found problematic with this model. Generally, images with more even lighting produce better texture generations. But the 3D model has picked up a lot of details, even adding some vegetation and what looks like furniture to these terraces. When you download all these GLB files, the easiest way to review all these, if you are using Windows, is to use the free Windows 3D viewer. You can pick your favorite ones. From here, you could drop these into Unreal Engine, but I recommend doing a few adjustments first. This could be done in some 3D software such as 3ds Max, but also in Blender, since it is open source. In Blender, drop to File, Import, and you can see the GLB file here. It will load the one that we just generated. You can see that this mesh is far from perfect and could be retopologized using more advanced tools in Blender, 3ds Max, or even AI tools, particularly useful for close-up detailed assets. I will show you some quicker methods instead, since I won't be using these models for close-ups. Both smoothing the edges and merging close vertices will suffice. To do this, select the object. Next, press Tab, go into Edit mode, and you can see all the vertices. Press M and select by distance. Down here on the bottom left, you can change the scale to be around 0.0001 or 0.001, depending on the scale of your object here. Go to Object in the toolbar and select Shade Smooth. One final useful edit is to move the pivot point to the base of the tower of the object, so that it is at 0, 0. And then press G to move the tower. If you also press Z, you can lock the Z direction. You can also hold Control to light snap to the grids. When you are happy with the positioning, you can go to Objects, Set Origin Mode, and then to 3D Cursor. So now we have a model that has been slightly cleaned up and a better origin point. Then go to File, Export, and select FBX. You can click Selected Objects and also uncheck animations and textures, as we don't have these here. Then press Export FBX. Over in Unreal Engine, I have a scene loaded up with Google Photorealistic tiles for context using the Season plugin. You can check out a previous video to learn how to do this. And now I can import all of my buildings, my sites. I will just make a new folder, make it clean. I will then import all the edited meshes first, without the textures. I'll simply drag all these FBX exported files and drop them into the folder. For the import options, you can keep Generate Collisions and change the scale here, or you can also scale it later on. I know my model is very small, so I'll keep the import scale at 10. I'll also not create any materials, as I'll add these later. Then I will press Import All. And we have 5 sculptural conceptual buildings. You drag one of these out, you see that it snaps to the flat surfaces, which is handy. I'll drop this into an empty area in the park, just as an example, where you can find better sites. But this will show you how the quality of these models matches the Google Photorealistic tiles at this stage. You can also then just start scaling and rotating and repositioning as usual. Now to add textures, I'll make another folder. This time I'll drag in all the original GLB files I downloaded. In the import options, we only need the textures and materials, not the mesh. You can check all these, or simply press Import and they can delete them after, which I will do. So select the models, delete these, and we're left with the materials and textures. If we double click the material, we have a standard material graph where you can adjust the parameters to make it more shiny or rough or add other maps. I will leave it as it is. I'll simply drag and drop this material onto the object and you have it fully textured. One of the great things about this model is that you can add lights or other assets to it, such as vegetation. As an example, I'll add a point light from the menu, bring it close to the windows of the model, and you will need to change intensity to a very high value. You could then place these in all the windows to illuminate them. I'll quickly speed through this to demonstrate. I'll make a folder to organize these lights, and you can select them all to change intensity. Another way is to do this through the light mixer, which you can find under Window over here. You can now adjust environment and lighting to your heart's content to achieve your composition. In the exact same way, you can bring in other options and drag the materials onto them one by one. These models can be turned on and off, for example, if they are design options or if you want to compare them. As you can see, they're very easy to generate, import, and manipulate. Quality is fine from a distance, and within this context, are once again not very good close up. Hopefully once the Nvidia Meshtron becomes available, it will be great to try this process again using their AI models for clean topologies and see the results. But the progress is still very exciting, and I hope you try this out for yourself.